in this projectile motion, the initial velocity of the particle is given to be 8 root 2 meters per second, whereas the initial angle of projection is not given. There is an additional information which is that the velocity of the object at the topmost point of its projectile is 8 meters per second. We need to find out the range of the projectile. So for going about this question, what we see here is that the x component of the velocity of the object in a projectile motion, if this is the initial velocity, this is v cos theta and this is v sin theta. If we consider the motion of the object in the x direction only, there is no acceleration in the x direction, so the velocity in the x direction of the object never changes. So the x component of the velocity of the object at every point of its projectile is v cos theta. So when the object is here, it is v cos theta, x component of the velocity. The x component of the velocity at this point is again v cos theta. So the x component of the velocity of the particle never changes. So at this point, the whole velocity is only the x component of the velocity. So we know that v cos theta is equal to 8 meters per second, whereas we know v to be 8 root 2 meters per second. We fill in the value here to get cos theta is equal to 1 upon root 2. So we get theta is equal to 45 degree. Now we need to find out the range. Range, as we know, is equal to u square sin 2 theta by g. We know theta is equal to 45 degree, therefore sin 2 theta is sin 90 degree, that is 1. Therefore we get the range as u square upon g, where u was the initial velocity, which is v. So u square comes out to be 128 upon 10, that is equal to 12.8 meters. So the final answer stands as the range of the projectile is 12.8 meters. The important thing which you should have noted in this question is that the x component of the velocity of the object is constant and never changes and is equal to the initial velocity into cos of the angle of initial projection.